All right, everybody. As we conclude investigation 2.3 today, um, we are going to, we started to kind of figure out yesterday how when we have to try to combine an equation where we have to find an equivalent expression, how we tackle that. And one of the things that we have to do um, is either multiply by to get basically the numbers the same, right? Because when you take away when you have like terms that get to zero, you either have to have the same sign, same number, and obviously you would subtract, or you would have the opposite sign, same number, where you would add. So we're going to kind of take that step further from number 4 in part A that we did yesterday and kind of take it a step further today. So with your worksheet out, you should be on part C. And it says, is system B below equivalent to system A? Explain. So if you have a little few-minute conversation to talk about it, and you're looking at both and you're really examining them, I want you to hit pause right now and just take a peek, and I want you and your partner to talk about if it's equivalent, why, if it's not, why, and then we're going to try to go through and prove it in problems 2 and 3. So if you pause the video right now, I'd like you to take 2 minutes, talk about if you think those two systems are equivalent, and why or why not. And then I want you, we're not going to talk about it out loud yet, we're going to go through and prove it right afterwards. So go ahead and hit pause. All right, so you've had your conversation, and we're going to start with number 2, where we're going to use the combination method to solve system B. Well, in system B, if you notice, we can't get rid of the x's, the 3x and the 8x, with any kind of addition or subtraction. But if you look at the y's here, okay, you'll notice that we have a plus 2y and a minus 2y. Okay, so we have opposite signs. So we can go ahead and add those. So we're going to write the expression out. We're going to combine the expression part. Okay, so again, I can combine like terms of 3x and 8x, which is 11x, and 2y plus a negative 2y is 0, and 10 plus 12 is 22. So once we combine or we eliminate our y's, we are left with 11x equals 22. And if we divide both sides by 11, we get x equals 2. So again, we found part of the answer to this system. Now we're going to take it and plug it into one of them. So let's plug it into the first one. I'm going to use a different color here. So 3 times 2 plus 2y equals 10. Well, 3 times 2 is 6. And when I have to subtract 6 to both sides because that's the opposite. So I get 2y equals 4. And when I divide both sides by 2, I get y equals 2. So I get the 0.22 as my answer. All right, I got to do one more thing to make sure I'm right, is I got to plug it into my other equation. So we have 8x, so 8 times 2 minus 2 times 2 equals 12. Well, 8 times 2 is 16. 2 times 2 is 4. And when I subtract 4 from 16, I get 12. And 12 does equal 12. So we solved system B. The answer is 2, 2. So now they're saying, well, check your solution to see basically if it satisfies system A. So we're going to take that 2, 2 we found in system B, and we're going to plug them into both equations in system A. If it solves both equations in system A, that means these two systems are equivalent. So if I take 3 times 2 plus 2, and that's a y, that's 2, equals 10. And then the other one is 4 times 2 minus, and then 2 for y equals 6. So let's go ahead and solve both of them. 3 times 2 is 6. 2 times 2 is 4. 6 plus 4 is 10. So 10 equals 10. So it solves the first equation. So let's see if it solves the second one. 4 times 2 is 8. And we already got the 2 there. 8 minus 2 is 6. 6 equals 6. So it does solve both of them. So that means system A is equivalent or is equal to system B. All right. And if you look at the top two equations, those are equivalent or they're the same because they're the exact same equation. If you look at the second one, okay, they're equivalent expressions because in the second one, in system B, all you did to system A was multiply every part by 2. So by multiplying it by 2, you came up with an equivalent expression. That's why the point works for both. So, hopefully that's what you and your partner talked about. If not, hopefully at least makes a little bit of sense now. But again, we did that little warm-up to get to this. And these last 4 problems will be, they get a little tougher as you go. So let's get to part D. And then you can go ahead and take care of your homework. So it says, for each system, write an equivalent system that is easy to solve using the combination method. And remember, we also referred to the combination method. Also, some books call it the elimination method. Solve the system and then check your solution. Check that your solution also satisfies the original system. So we have to plug it back into the original. So let's start with number 1. If I look at number 1 right now, if I add or subtracted both equations, I cannot get an elimination here, or can't combine anything either to get 0. I can't get rid of an x or a y. So now let's look at the x's. Do we have, is 2 a multiple of 3 or is 3 a multiple of 2? No. 2 can't go into 3 evenly, 3 can't go into 2 evenly. So let's look at the y's. Can 2 go into 6 evenly? Yes. All right. So 2 can go into 6 3 times. So I can make 2y 6y by multiplying the entire top equation by 3. And that should eliminate our y's. So let's rewrite the systems here. If I take this expression here and multiply the whole thing by 3, that means every single term, all right, I would get 6x plus 6y. Oops, that's a y. I'll erase that because that's terrible handwriting. Equals 15. And then I'm just going to copy the other one down because we didn't need to adjust that. All right, so let's go ahead and combine. And again, opposite signs so we can add them. All right, so combine like terms. 6x plus 3x is 9x. The 6y minus 6y is 0. And on the right-hand side, I get 15 plus 12 is 27. All right, so since I got 9x plus equals 27, very easily, I can divide both sides by 9 because that's a multiplication. So I undo the opposite by dividing. That becomes 1, leaving me just x. And 27 divided by 9 is 3. So 3 is hopefully one of my points to my system. So now I'm going to go through and I'm going to plug in the 3 for one of them. Let's plug it into the top one. We'll do this in a different color. All right, so if I plug in 3 up here, we're going to say 2 times 3 plus 2y equals 5. That gives me 6. 2 times 3 is 6. And to move the 6 over, I need to subtract 6 to both sides. So I get 2y equals, and 5 minus 6 is negative 1. All right. So to get y by itself, I got to divide both sides by 2. And that gives me y by itself because 2 divided by 2 is 1. And I get negative 1/2, or basically we can just write it as a decimal, negative 0.5. So we have to see if these 2 points work in the other equation. So I got to go plug it into the second one. So we're going to say 3 times 3 minus 6 times negative 0.5, or a half, equals 12. Well, 3 times 3 is 9 minus, and then 6 times negative a half is negative 3. And since I have a double negative, remember math is the only place where two wrongs make a right. That becomes positive. 12 equals 12, and we just solved that system. So those two lines would intersect at the coordinate 3, negative 1/2. All right, number 2. Number 2, if we look at it, we look at the x's compared to the y's. We have a 1 in front of that top x. 1 goes into anything. So our x's are going to be where we want to combine. So I can take that top equation and multiply it by 4. So by doing that, I would have 4x, so this whole thing, by 4. So every single term is being multiplied by 4. So 12y equals 16. And then over here I have 4x plus 5y equals 2. Well, now I got same sign, same number. Well, that means I can subtract. So now, let's block this off here so I can organize everything. All right, so now I'm going to subtract. So 4x plus 12y minus 4x plus 5y and 16 minus 2. So 4x minus 4x is 0. That goes away. So we're going to have just a y here. 12y minus 5y is 7y. And 16 minus 2 is 14. So to get y by itself, I got to divide both sides by 7. 7 divided by 7 is 1. And 14 divided by 7 is 2. So we found the y coordinate of our system, 2. Now I can go back up to the original system, okay? Meaning, if I just get rid of this so it doesn't confuse me, I'd say the top one is going to be the easier one to work with, right? So if I plug in a 2 for y, I get x plus 3 times 2 equals 4. All right. Well, 3 times 2 is 6. And to get x by itself, all I got to do is subtract 6 to both sides. So x is going to equal, what's 4 minus 6? Right, negative 2. So x is negative 2. So now I got to test it in the second equation here to make sure it checks out both equations. So if x is negative 2, 4 times negative 2 plus 5 times 2, because y is 2, and that hopefully will equal 2. Well, 4 times negative 2 is negative 8, and 5 times 2 is 10. And when I take 10 and add it to negative 8, I get 2. 2 does equal 2. That checks. So the answer to that system, using our combination or elimination method, is negative 2, 2. All right. All right, so 2 down, 2 to go. Well, now, again, if you look at number 3, again, it's trying to find a variable that we can eliminate. 2 can't go into 3, and 3 can't go into 2. But if you notice, one of our y's is a 1. And like we said before, 1 can go into anything. So I want to take this whole expression right here and multiply 2 into it. So when I do that, I get 4x plus 2y equals 5. And if I just recopy the other equation, I can easily see where my combining the terms, where I'm going to eliminate my variable. We are going to eliminate the y, because I got a plus 2y and a minus 2y, right? I can't subtract them because the signs are opposite. So I need to combine both equations by adding them. Okay, so 4x plus 2y, and we're going to add that to 3x minus 2y, and then we're going to add both of our numbers together on the other side of the equal sign. So again, combining like terms, 4x plus 3x is 7x. 2y plus a negative 2y is 0. And 5 plus 15. You probably caught my mistake before I did. I made a big mistake, didn't I? When we multiply 2 through, this 5 should be a 10. And that's obviously going to make this 25. So now when I go through and divide by 7, 25 sevenths is going to give us a decimal. And 25 divided by 7 is 3.5714, so on and so forth. That's a big, long decimal here. And it's a repeating decimal. Repeats every 6 digits. All right. So there's our x. Ugly, ugly, ugly number. Well, so we found our x to be that. Not a fun number to work with, but we're going to work with it nonetheless. So if we plug this into the top equation here, we'll break this down here. And that's our x. So I'm going to take, I just found that number, I'm going to multiply it by 2. And when I multiply it by 2, so we're going to plug this into the top equation here. All right, so 2 times this number is 7.142857. Again, a repeating decimal. Plus y equals 5. So now, when I take 5 and subtract it, and I'm just going to put 142857, all right? So I'm going to subtract that to both sides. All right, I get y equals negative 2.142857, and that's repeating. This is not a pretty looking number, ladies and gentlemen. Okay. Well, we gotta make sure it works. So I'm gonna use my calculator here because we got some ugly, 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 ugly decimals. So to plug this into the second equation, make sure it works. 3 times, this is gonna be 3.571428. And I'm just going to put another 571428 just to try to make it as accurate as I can. All right, I get 10.74285, and that repeats every 6 digits again. And we're going to subtract that from, and we're going to take 2, and we're going to multiply 2 times negative 2.142857, 142857. I just repeated it twice just to help my calculator out. And since I got a negative times a negative number, that's going to make this a plus. And we get 4.285714, which is here. And that has to equal 15. But as crazy as this may look, when I take 10.714285 and add it to 4.285714, we literally get, and again, because it's rounded, it's a repeating decimal, you get 14.999999, which is basically 15. We actually end up getting 15 equals 15 to prove that that's right. Well, that is one ugly looking problem. Ugly, 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 ugly. But we did it nonetheless. We persevered. So here's what I want you to do. I want you to take a couple minutes and see if you can find number 4. And then we will say 5 minutes, see if you can solve number 4, and then we will go on from there. All right. Well, we are back with number 4. Let's see how you did. Let's see if you can wrap this up here before you can turn you loose on your homework. Well, again, if I look at both equations, the top one, I can't go wrong with either way, right? they both can go into, I got a -1, which goes into any number, and 2 goes into 10. So if I take this top equation and multiply it by 5, I get -5x plus 10y equals 25. And then the bottom one I'm just going to recopy as 5x minus 10y equals 11. Well, here's my problem. Here's my issue. I'm going to go ahead and I got opposite signs, right? So if I go ahead and add them together, so -5x plus 10y, and we're going to add 5x minus 10y, that equals 25 plus 11. Okay, well, if I go ahead and combine like terms, -5x plus 5x, 0. So if I go to combine my other like terms, 10y minus plus a -10y, well, that's 0. So I get 0 on the left side equals 36. What happens here? Not good, right? We've learned in the past that this is no solution. Why is that? Well, if I take this first equation and put it in a slope-intercept form, I add x to both sides, and I get 2y equals x plus 5, and divide by 2. I get y equals 1/2 x plus 5/2. And if I do the same thing with the other equation, if I subtract 5x to both sides, I'm left with -10y equals -5x plus 11. And I go ahead and divide everything through by -10, because again, I'm going to get it in y equals mx plus b. I get 1/2 x minus 11/10. Well, look what we get here. The slopes of the two lines are the same, but the y-intercepts are different. Well, by definition, that is what? You are correct. Parallel lines. And parallel lines do not intersect, which is why we came up with 0 equals 36, and why that is no solution. So I am going to turn you loose on your homework. This video will stay up so you can access it at any time. Rewatch it a couple times if you need to help you. But your homework then will be this, and you can pause this to leave it up. On page 34, you're doing 23 to 31. That's all of them. And then on page 39, you are doing 70 and 71. All right. And if you open your books, see page 34, 23 to 31 there, those are all systems using the combination method. Okay. Nothing new there. That's what we've been doing. If you turn to page 70 and 71, okay, that's a little practice as a review, combining equations with combining or solving equations for x. There's only one variable here. You got variables on both sides. All right, so that's just a little bit of a review. All right, so you can use your remaining class time to do your homework. I hope you found this lesson valuable, and I will see you guys on Monday.